All right, next up is going to be Ian Lewis talking about Kubernetes security.
All right. How's everybody doing? Oh, I got somebody to react to me. So today I'm going to be talking about Kubernetes security best practices. This is going to be pretty high level overview. I'm not going to get too deep on this stuff, but by way of introductions, I'm Ian. I work at Google. I'm based in Tokyo, Japan, and I do a lot of Kubernetes-related stuff, Go, and I have a background mostly in Python development. So I heard earlier that some folks were kind of waiting for Python 4 before they migrate. So just to let you know that I'm waiting for Python 4 too. I'm kind of a Python 2 person. I kind of skipped the odd-numbered versions. And if you're a Python 3 person that really likes that, So how many of you have actually touched Kubernetes, have run kubectl? Okay, yeah, like pretty much everybody. So I won't need to tell you that Kubernetes, describing Kubernetes as a container orchestrator is kind of a misnomer. It's a lot of things. I like to think of it as an operations framework. So it provides a lot of features that you can use to do operations, make things more fluid, that sort of thing. But you guys know all this already. So today, what I'm going to talk about mostly is I'm going to talk about several different best practices that you can do when you're deploying applications. And so I'm going to use this little guestbook app that I wrote. It's kind of a microservice-y architecture. It's got a little message application it's basically just a gRPC service that you can use to save messages in a list, and that saves it back in Redis store. And then we've got an ng-word message or service, and that's basically just to check if you're saying bad words in your messages. We want to keep things G-rated. So there's that service, and then we have a little web front-end application. So to look at it, it looks just like this. Everybody's seen one of these things. You can say hi FOSDEM, and you run that, and it writes it into the list, yada yada yada. Okay, but this one also has it's has a little ng-word check system. So if you do hoge, which is this is a word that I have registered in there. I didn't actually register bad words, and because I wasn't going to do that during this talk. But it pops up and says hey, you can't write that. All right. So we have this little application. It works like this. This is the kind of flow. So the first thing that you might do when you're thinking about attacking a system like this that's running in Kubernetes is you might think, hey, why don't I just try to take over the API server for the cluster? Typically, or a lot of times, folks will have an API server that is exposed to the internet, and normally you would have to authenticate with it using certs, and it's not too big of a deal that it's exposed to the internet, but one way that you could attack it is attack an application is to attack the cluster itself. So if you're familiar with Kubernetes, you'll know that applications, each pod can get a service account, and that service account can be used to authenticate with the API. And so one way that you might do that is to, if you've got control of, say, the front end, is to then take that token and then access the API. And then use that to get secrets to then further attack the system. So you might do something like, don't judge, I have a cheat sheet here. So here what I'm going to do is I'm going to assume that you have access to run just basically arbitrary commands inside of the front end. You've broken in, there was some sort of bug in the front end that you used to break in, and so what you're going to do here is we're just going to run kubectl exec into the front end, and we're going to cat out this token that's saved from the service account. And so what you can do from that is then, I have this long command here, to actually this will run and call the Kubernetes API to get secrets, and then parse out the, using that token, and then parse out the Redis password for our database. And so we get out this database here, and so we can do like telnet. Let's actually go into that pod first. So if we do this, whoa, exec ti, oh yes, I need to say bin bash. So I've got like a little one equals space. Okay, that's better. So we'll do telnet, Redis, and 6379, and then we'll just like auth with this password that we got up here. Right, so then I can just be like, hey, give me out all the messages. And then we'll say like 0, -1. And that like, gives us out our messages. You can imagine maybe like we have, hey, somebody else has been posting into my guest book. Yeah, that's a public IP address, so if you... So if you want to play along at home, you can post stuff there. But let's see. So that's the idea. I mean, if you had like maybe some user data or some other like kind of stuff that would be exposed, then that would probably be a bad thing for you. So one way that you can kind of mitigate that is to, let's go back to the slides here. To use RBAC. So RBAC is role-based access control for Kubernetes, and this allows you to basically create roles that you can assign to users, and then that role gets assigned some permissions that it can do. So like usually that's like some sort of verb to a type of object. So like get secrets is one that you probably you want to give away sparingly. This particular cluster is already set up to use RBAC, so I'm kind of emulating the fact that that I have access to everything. But if you actually were not using RBAC, then by default your service accounts just kind of get access to the full Kubernetes API. So here I'm just going to like delete the web binding or the cluster role binding that I had for that service account. And now if I go back and try to do this again, I probably don't need to do that, but if I try to do this guy again, I should get back that I don't actually get the password back. And if we look at just this part, I think, no, let's just get this part. That one right there. We can actually see the result that comes back, that it's like, hey, you can't access the secrets. All right. So RBAC's a thing, you should use it. That's pretty much, if you're using a recent version of Kubernetes, it's pretty much always, or it's pretty much enabled by default. Let's see, like the next thing is to actually put a firewall in front of the API server. So if you want to, you can like kind of limit the folks that can actually access the API server by IP addresses or by networks. So if you're somebody that's using it on GKE or on at Google, then you can create your cluster and set the authorized networks that can access the API server. Or if you're like running this on-prem or whatever, then you can kind of use whatever method that you want to firewall that. But that's another idea, because that will make it so that folks can't actually access the API server externally. Of course, they can still tunnel through the front end if they have access to it. Another idea is to use network policy. So network policy allows you to, at the network level, say like, this pod can access this pod, or this pod can't access this pod, and that sort of thing. And you can set that up by pod labels. So here we have a pod selector that matches the Redis server, and then we'll say that that only guestbook applications, or the guestbook application, can have access to ingress into the Redis cluster. So if I go back here and I say apply network policy like that, and then I say bash, and I try to do that telnet thing again. Redis 6379. Yeah, I just can't connect to it anymore. It's that one, I think. No, telnet, you just don't like me. Okay. All right, so that's actually this type of thing, getting access to the API server. So once you've kind of blocked off access to the API server, you've locked that down. Another thing that you might try to do if you were an attacker would be to kind of break out of the container and then try to get access to the host and take over the host, maybe attack other containers that are running on that host, maybe attack the kubelet that's running on that particular server. And so those type of things you can kind of try to mitigate a little bit better using a few features. So if you're familiar with things like setcomp and AppArmor and SE Linux, those are things that you can use to kind of help mitigate this. So your app running just by itself is fine, but when you put it into a container, it helps it to so that it's harder to break out of it, but it's not always it's a little bit porous in the sense that if there's a kernel exploit or some sort of problem that you could have within the kernel, that could potentially allow you to get out. And so what you do after you've put your application into a container, or you've caged it up, you put it in a lockbox, and then you put it in another lockbox. So these, so using these really help it so that even if you're able to kind of break out of the container, you still can't really do very much that's useful. And so setcomp does that by allowing you to create a filter, a whitelist filter on the syscalls that you can do. AppArmor and SE Linux are both the security frameworks for Linux, so they can stop you from doing things like mounting things, extra stuff inside the container, or writing to proc, or doing things like that. So kind of by default, Kubernetes doesn't really allow, have you set this, or doesn't set a setcomp profile for you. So it's pretty recommended, at least by me, to go ahead and put in that, because otherwise you'll have things where we are going here. Let's go back into our little guy here, and we can say okay, well, we're going to just unshare the user namespace. Oh, wow, I can just do that. So if there's that doesn't really necessarily by default, or as it is, let me do very much that's useful, but you can imagine if there was some sort of exploit that through unsharing a namespace that allowed me to break out of the container, that this would be actually a bad thing for me to be doing. Most applications don't need to do this, and so if you just say well, you can't do that at all, then that will help mitigate those type of problems. So we can go in here. Let's see, and we'll say in the web app, deploy, let's go ahead and add that in. This is really, all right. So now I updated that so that it's so that this web server now has a setcomp profile, the default setcomp profile running on it. So I could say like kubectl exec that guy, and then like, so in here I can try like unshare again. Yeah. So like by default, like, so if I use the default seccomp profile for Docker, that is not whitelisted. So I can't actually do that if I'm actually applying the default seccomp profiles. So when you want to, so if you're, most applications will run just fine with these. And so you'll want to just go ahead and do that if you're running an application. Like also the AppArmor, depending on which provider you're using or whatever, however your cluster is set up, you might have AppArmor installed or you might have SE Linux installed. And so you can kind of go ahead and use the default, the Docker default, or the runtime default profiles for AppArmor and SE Linux as well. So here, the AppArmor one is just the default, and then you can set your own SE Linux options within the security context in a pod. So those are things that are like pretty nice to just go ahead and do. Another thing is that you might want to restrict the permissions that the kubelet has. So if you're, say, trying to, once the person has got out of the container and then like gets access to the kubelet and the kubelet's tokens and certificates, then they can basically do whatever the kubelet can do. And so if you restrict what the kubelet can actually do, then that can help you kind of mitigate problems. Oh god damn it. There we go. So one thing is to enable like the RBAC mode for the kubelet, and then set node restriction. So that means that each kubelet only has access to things like secrets that are running for pods that are running on that node, and so it won't have access to secrets that are available on other nodes or for pods that are not running on that node. Also, setting the certificates to rotate is also helpful, so that like if somebody extracts the certificate for that kubelet and then tries to use it against the API server, that it will eventually get rotated, or it will get rotated relatively quickly, so that they won't be, once you've kicked out the attacker from your cluster, they won't be able to just still use that certificate in perpetuity. So another issue that you might kind of run into is listening to traffic within the cluster. So like once they have access to the web front end, they might be able to, like, say, listen to the traffic between our message service and Redis, and pick up the password or pick up like some data that's being transferred, and use that to attack, or just extract the data. So that sort of thing is also not particularly good. And you can also think of the host perhaps making requests to other services within the cluster. So creating essentially fraudulent requests to other services. So this is something that even if you use gRPC, you're not really, that's not really going to stop somebody from sending just gRPC requests to the server. They're a little bit harder to do than just sending a curl request, but there's nothing stopping an attacker really from doing that. So that's where things like service meshes come in. So Istio is a service mesh that's you can run on top of Kubernetes, and what it does is it includes an Envoy proxy as a sidecar for each of your containers, and then the Envoy proxies for each of those sidecars essentially are the ones that talk to each other, and all of the applications just talk to the sidecar. So you go from the application to the sidecar proxy, then that sidecar proxy goes to the other pod sidecar proxy, and then up into the application. And everything in between the sidecar proxy is authenticated and encrypted. So the way that it looks is it looks kind of something like this, where you have this little sidecar proxy running on each of your applications, and then the communication in between them is authenticated and encrypted. So you can't really, from the web front end, like listen in between the what the message service and the Redis service are doing. And then you also can't as easily just send requests to a particular service because you're not authenticated with that service. As part of this, you can create like policies for which services can talk to which services. And so maybe our front end can send messages to the message service, but if you had another service out here that message used and the web front end didn't access directly, you wouldn't be able to send from the web front end messages to the other one because you would run into the policy would forbid that. And so that makes it a lot easier so that like people can't really do very much once they're inside the cluster. So another issue is like that once you've taken control of the web front end, the attacker could then potentially gain access to the sidecar, the actual Envoy proxy running the sidecar. Okay, yeah. And so this also does like the kubelet and does rolling certificate updates. So like even if you've extracted that certificate, you can't really continue to use that certificate forever. And that's it, really. So apparently I have 5 minutes left, but maybe not. 4 minutes for questions.
All right.
You sort of skimmed over this fast with the RBAC stuff at the start. Once you have access to a specific thing like the web front end,
right.
Can you not from there just then talk directly to Kubernetes API server and, for instance, kubectl exec on another machine? How do the...
So no, so like the reason why I can exec into it is like because I'm a cluster administrator myself, and so I'm just assuming that like I can get into the front end. Like in this case, I'm execing into it, but like that wouldn't be like how an attacker is actually getting into it. They would be doing it through like through some sort of tunnel that they've created.
So I'll try and be a bit more concrete. One of our clusters at the moment has a Jenkins thing inside it, which then has permissions to start up and destroy other containers.
Right.
Which then means that any of those pods have permissions to do basically everything.
Not necessarily.
That's something that needs to be set up via
so your Jenkins server for sure like would have permissions to do a lot, but the pods that Jenkins creates don't necessarily have to be able to do everything. You can set up the roles in such a way that they only are able to do what they need to do.
Okay. So yeah. Great,
right.
Thanks.
Yeah.
So one of the things Docker really got right was having a good default seccomp profile. Do I need to explicitly enable this in Kubernetes?
Can you say that again?
So one thing Docker got right was having a good seccomp default profile. Do I need to explicitly enable in Kubernetes to get a default seccomp profile? So
if you kind of install it by default right now, like yes, and I believe that's mostly because it's still like kind of an alpha thing. I imagine that will become like kind of a default in the future. And it also depends, like, it could depend on the vendor or like whoever's like setting it up for you. Like, so I believe right now like GKE doesn't do that, but in the future it will be, you'll probably have default security policies that enable those default seccomp profiles and default like AppArmor profiles and stuff like that.
But will also like with the CRI and all these new container runtimes, will they also have to support the same format of seccomp profile? Right.
They would have to support setting the seccomp profiles as part of like their execution framework or however they start up the containers. But yes, like the way that it was set there, say like runtime default, is so that you basically have a way of setting the default that runtime, whatever runtime gives you. There's also like, you can also put it in, if you know it's Docker, you can just say Docker/default. Yeah.
Yes, this is just to bounce on what he was asking a little bit. How many of the recommendations that you suggested are implemented by managed Kubernetes like GKE? Like, especially like the kubelet, we're not really, GKE users can't really start adding flags, startup flags, or not to my knowledge. And
Right.
we kind of have like everything, like the API server and the scheduler are kind of hidden away, so there's no really way we could actually install like some additional security.
Yeah, things are kind of like getting better as like things are going on, but like so things like if you create a server that's like on GKE, for instance, like if you create a 1.8 cluster, like by default RBAC is there and like everything works fine. So if you create a pod like with that pod's service account, like really can't do anything. So as things go on, like more and more things will become default. Yeah, you don't really have at the moment like a lot of flexibility in terms of like turning those flags on and off unless that particular vendor supports it.
Network policies, I think, are an alpha feature, and alpha clusters kind of get destroyed after a month.
Right. Network policy, I believe, is actually not in alpha anymore. It's in beta, if I think.
I actually have a 2% traffic loss that I'm seeing constantly when I enable that. So.
Yeah, that depends on the network implementation, really. Like, I mean, you're probably using Calico or something like that, right? What's that?
That's GKE plus Calico.
Yeah. Network policy is actually implemented by Calico on GKE. So, like, yeah, like, and I believe that it's probably, I believe it's using IP tables underneath the like, and setting those rules so that you can't access. But yeah, hopefully that'll improve in the future. I don't know offhand. Like,
there's a bug fixed in 2.6.
Yeah. So I believe that'll get better, but yeah, there is a little bit of network cost for things like network policy.
All right.
I think that's all the time we have.
It is, yeah, we're out of time.
Thanks a lot.
Thank you very much.